Hi, welcome again. And today we're going to learn more about probability and probability distributions. In week 4, we started learning about probability. And so we define probability. We look at the rules, or we call basic rules of probability and so forth. And also, we started looking at the probability distribution when we have distribution of values, let's say values in variable x, and so we look at their corresponding probabilities, and those values are estimated. So that is we looked at that distribution of data in with their corresponding probabilities. Week 5, we started looking at probability distribution of discrete random variables. So probability distributions of discrete random variables are several. For instance, we have a binomial distribution, which is probability distribution of a discrete random variable. And also we have Poisson distribution as well as exponential probability distribution. Those three are probability distributions of discrete random variables. We say discrete random variables because we are dealing with the whole numbers. Let's say 0, 1, 2, 3, and so forth. We don't include continuous variables or values that have decimal points. So discrete values are the values that we can assign probability to a particular value. And so the distributions which I just mentioned, which are binomial distribution, exponential distribution, and Poisson distribution, are the kind of discrete random variables or probability distributions of the discrete random variables. Now, in week 6, we learned about binomial distribution. And also, I mentioned about Poisson distribution, which is close to the binomial distribution, and also exponential distribution. So in this lecture, we're going to look at the binomial distribution and how it works. So I'm going to open the notes where I develop just the summary of the binomial distribution, and then we'll start working on some examples. So if you can open this Excel file, I'm going to post it in week 6. So we have notes for binomial distribution where I actually made some summary. And then we'll work on some examples. We have example 1, example 2, and so forth. So the binomial distribution, as I said, it involves the discrete numbers or discrete values. We don't include decimal points. So here we have 0, 1, 2, 3, and so forth. Those are the discrete values. Now, binomial distribution has a number of characteristics. Actually, there are 4. So the first characteristic of the binomial distribution, it means that we have trials. And normally, binomial distribution is done in an experiment. And in this experiment, there are a fixed number of trials, which can be denoted by n. And so the trial will come up with two possible outcomes. So the first outcome is either the success, and the second one is the failure. So either you get success or you fail for each trial. So in this case, you can actually, the success is when you get yes, and failure is when you get no. For instance, if you are making an experiment of picking a boy or a girl, So we will look at the purpose, what you're looking for. So the purpose here, for instance, if we are interested to pick up a girl, so success is when you pick up the girl because you're interested with picking a girl. So if you pick up a girl, then that is the success. But if you pick up the boy, then that is failure. When we flipped coin in the other lecture, we saw that there are two outcomes as well. You can either get head or you can get tail. So let's say your interest is to get tail. In this case, if you get tail, then that means it is a success. And if you get head, then that means it is the failure. So all I want you to know is in the experiment, there are two outcomes. One is success and the other one is failure. And so the probability of success is denoted by P, or probability, and then the probability of failure is denoted by 1 minus probability of success. So in this case, we are actually applying one of the basic rules of probability, which is the complementary rule. In the complementary rule, we look at success, and the complement of success is fail. And we saw that probability of success probability of success plus probability of failure equals to 1 because we have exhausted all the possibilities. Now, if we know probability of success, to know the probability of failure, we'll take 1 minus probability of success, and so we get that probability, which is probability of failure. And we'll learn about this when we discussed about the complementary rule of probability. So that's the second characteristic. Now, the third characteristic says that the trials are independent and are repeated using identical condition. So consider when we flip up the coin. So you just flip up the coin once and you have your outcomes, either success or failure. When you repeat flipping the coin using the same identical conditions, the trial is independent of the first trial, meaning that the first trial will not determine the outcome of the second trial. Each one is independent. You will flip coin under the same conditions many times, and the outcome or the first outcome will not determine the second outcome. So that is the third characteristic. Now, the fourth characteristic says that for each individual trial, the probability of success and probability of failure remain the same. For instance, let's say the probability of getting success or the probability of success is 0.4. So the probability of failure should be 0.6. When you add, you get 1. And therefore, for the whole experiment, probabilities should remain the same. So if you flip the coin once, the chance of getting, or the chance of succeeding, or the chance of failure, as we said, could be 0.4 and 0.6. The second experiment will depend on the same probability because they are constant for the whole experiment. So I want you to remember about those. So we have those 4 characteristics that will help us to identify the binomial distribution kind of question and be able to differentiate this with other kind of distributions. So how do we find average and standard deviation of binomial distribution? We can find average of the binomial distribution, which is mu, and it is the number or the n times probability of success, the number of trials times the probability of success. And also we can find the standard deviation of the binomial distribution, which will be the square root of n times probability of success times the square root of of the average times the probability of failure, which is n times probability of success times 1 minus probability of failure. So these are important formulas that we'll use when we have to find the average and standard deviations of the binomial distribution. Now, we need to use Excel function to find to calculate binomial distribution kind of questions. So the function is binom.dist, and we have a number of characteristics or things that we need to fill into the formula. You could actually use binom.dist. Let me write here. You could use binom.dist, binom.dist, and get results as well. As I mentioned before, these are for Windows 2007 and beyond. So in your Excel, you can actually find binom.dist or you can find binom.dist. So let me go to this side of Excel and show you. If you put equal sign and type binom, so you can see we have binom.dist. Let me make sure that this is so you can see that we have binom.dist, and we could also write binom.dist, and that also will work. So you can either go with the binom.dist or binom.dist, and you can see here we have you're supposed to put number of numbers S, which is actually the X, and the trials, probability, and cumulative, which is the logic factor. So what is X? When you type, let's use binom.dist. So if we go with the binom.dist, you can see the same. So number dash S means actually number of success, and we can consider that to be X. What are we looking for? Are you looking for a girl, or are you looking for let's say when you flip the coin, is your X head or tail? Which one did you choose? If you chose tail, so that means that will be number of success, that is X. Now N, number of trials is N. So we look at how many times do we conduct this experiment. Are you flipping the coin 3 times or more? Let's say 20 times or whatever. So that is the number of trials. How many times you are taking this experiment. Now, P is the probability of success, as we said before. And that probability here is probability of success. And the logic factor, which looks at the kind of cumulative that you have. So that's what I want to discuss. Now, the logic factor will be either false or true. False if the is for the probability of exact, and true is for the probability of at most. So what does it mean by probability of exact? Probability of exact can be written as this. So where let me remove this. So probability of exact is when we have probability of X such that X equals to a value. Xi is a value. And probability of at most, it says probability of X such that X is less or equal to a value. So those are the two conditions that we need to apply when we use binom.dist. You cannot say probability of X less than a value, or probability of X such that X is greater than a value. So remember, X should be the xi must be integers. So here xi. So they should be integers. Now, let's assume that our xi is 4. So if we are supposed to find probability of x such that x is less than 4, we cannot use binomial distribution because this is not the probability of exact or probability of at most. So we have to bring this to be either probability of exact or probability of at most, but that is a cumulative. So in this case, we can say probability of x such that x is less than 4. We are looking at the next value, which is less than 4, which means it is 3. Because we count 0, 1, 2, 3, 4. They should be discrete values. So probability of x such that x is less than 4, actually we're looking at the probability of x such that x is less or equal to 3. So that means we will start with from 3 to 1 and 0. Those are the values which are less than 4. So we start with probability of x such that x is less or equal to 3. And so 3 is at most. Now let's say if you are asked to find probability of x such that x is greater than 4. That is not the probability of at most. It is the probability of greater than. So we need to transform this to probability of at most. So what we're going to do is we'll use the same principle that we used in our complementary rule. So we'll take 1 minus probability of x. If you can see here, 4 is not included. We are asked probability of x such that x is greater than 4. Since 4 is not included, so we will include it here. And therefore, we're going to have 1 minus probability of x such that x is less or equal to 4. And finally, if the question asks you to find probability of x such that x is greater or equal to 4, you can see that 4 is included. And therefore, we should change this to be written as 1 minus, because anything greater, we have to bring it to less. And we can do so by taking 1 minus probability of x such that x is less than 4, because here 4 is included. But still, this is not at most. It is less than 4. So what is less than 4? It is from 3 to 1 and 0. So we'll take 1 minus probability of x such that x is less or equal to 3. So that are our notes, and we'll start working on some examples. So let us now try to work on some examples. And so the file that is posted has this example, which is binomial Excel function example number 1. So here is the question. It says, it has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. Suppose 20 adult workers are randomly selected. So how many adult workers in the sample do you expect to have a high school diploma but do not pursue any further education? What is the probability that exactly 8 of the workers in the sample have a high school diploma but do not pursue further education? And finally, what is the probability that at most 12 of the workers in the sample have a high school diploma but do not pursue further education? So in this case, there are a number of things that we need to identify here. So we want to find out if this information satisfy the characteristics of the binomial distribution. And the first thing that we said we need to find I'm going to skip one line here. We need to see if we have the trials, because according to the notes, let me go back here very quickly. We say that the first characteristics is that we need to know a fixed number of trials. So in this case, the number of trials should be the 20 adults who are randomly selected, and that is fixed. So we can say n is 20. So skip the line here and put 20 there. Now we need to find the probability of success, which is P. Do we have probability of success? So the probability of success here is actually 41%. It says it has been stated that about 41% of adult workers have a high school diploma. That 41% is the success. So what is the probability of adults who have no high school diploma? So we take 1 minus probability of success, which means we're going to put equal sign and type 1 minus 41. Put equal sign there, and then type 1 minus probability of success, which is 41%. I'll change that number, so enter. Now I'm going to make this 41%. So the outcome will be 59%, or 0.5 is the probability of failure. Now let me put it into percentage. So 59% is the probability of failure, or the probability of high school, of the adult workers who have no high school diploma, or who have high school diploma but pursued further education. So that's the opposite of what we are looking for. It is the complementary or the complement of the high school diploma but no further education. So here we have satisfied that, and I'm going to go back here. So what is our X? So X is what we are interested about, and this is the adult workers who have high school diploma but no further education. That is our interest. The high school diploma, the adults with high school diploma but they don't have further education. So these are the information which we have so far, and let's see if we can use that information to respond to the questions. But before even we go there, you can see that this actually this information satisfies the characteristics of the binomial distribution, because we have n number of trials, we have probability of success and probability of failure, and these are constant for any experiment. This experiment or the trial is independent of the other, meaning that these 20 adults are selected randomly, meaning that when one person is selected, the selection will not determine the next selection, and so forth. So we can say that this satisfies the binomial distribution characteristics, and so we can call this as a binomial distribution kind of question. So the first question says, how many adult workers in the sample do you expect to have a high school diploma but do not pursue any further education? So this question actually says we are looking at the average of the adult workers who completed a high school diploma but didn't pursue further education. And so when we go back to the notes, you can see the average. The average of the binomial distribution is given as mu equals to number of trials times the probability of success. So I'm going to copy that formula and paste it here. So that's all we're looking for. And in this case, I'm going to put equal sign, and we have 20, and that will be times probability of success, which is 41, and then enter. So that will give us actually the average of the number of adults that have a high school diploma but didn't pursue further education. So we can write here, conclusion. We can say that on average, in any sample of 20 workers, so we have 8.2. So 8.2 have high school diploma but no further education. So that's actually the answer to the first question. Now let's look at the second question. The second question says, what is the probability that exactly 8 of the workers in this sample have a high school diploma but do not pursue further education? So we are looking at the probability of X such that X equals to 8, exactly 8. And we know that for binomial distribution, all we need is the probability of exact or probability of at most. Probability of at most is where we have X is less or equal to a value. So in this case, we can actually apply the binomial distribution because it is possible to do so. So let me put this on top. So in this case, we're going to use formula and use binom. As I said before, we could use binom dist, or we can use binom dot dist. So I'm going to click binom dot dist. And so the first thing we're looking for is the number S, which is actually the X. And in our case, X is 8. And second, we are looking at the trials, the number of trials, which is 20. And then we are looking at the probability of success, which is 41%. And then we just keep putting comma. And now, should we write true, meaning that it is a cumulative distribution, or false? It is false because we are looking at the probability of exact. If it was less or equal, then that is cumulative, and therefore we'll say true. So I'm going to type false, or I will select the false here. If you select it and close the bracket, now you can enter. And in this case, you can see we have 0.17896. So that is the probability that exact 8 workers from the sample have high school diploma but no further education. It is 0.1786. So let's look at another example. Now, please provide your conclusion. Says the probability of the exact 8 of the workers in the sample that have high school diploma but no further education is 0.17896. So let's look at the third question. It says, what is the probability that at most 12 of the workers in this sample have high school diploma? So we need to define that probability, and we can write probability of X such that X is less or equal, that is the at most, equals to 12. So this also satisfies the probability condition. It satisfies the binomial distribution Excel function because it's less or equal. And therefore, all we have to do is just to put equal sign and type binom and select binom dist and do the same. So we know that in this case here, we are looking at the probability that at most 12 workers. So we're going to write 12 workers. And then the number of trials are the same, which is 20, put comma, and then probability of success, which is 41%, and then put comma, and then cumulative. So this is not false because it's not exact, but it is true. It is cumulative. So I'm going to click there and close the bracket. And if you can enter, you will see our results. We have an outcome of 0.97378 as the probability that at most 12 workers in the sample have high school diploma but did not pursue further education. So let's work on example number 2. And so this says about 32 of the students participate in a community volunteer program outside of school. 32% of students participate in a community volunteer program outside of school. So suppose 30 students are selected at random. What is the expected number of students in the sample that participate in a community volunteer program? What is the probability that exactly 10 of the students in the sample participated in a community volunteer program? And what is the probability that at most 14 of the students in the sample participated in a community volunteer program? I will add more to this section so that we can learn more than having exact and at most. So let me add more here. So let's go to 4. So 4, what is the probability that at least, let me just pick a number, at least 6 of the students in the sample participated in a community volunteer program. So we're looking at the probability at least, and let me add one more. That's number 5, and I'm just making up some values so that let me copy this and add it here. So what is the probability that more than 6 of the students in the sample participated in a community volunteer program? So I think that will be enough to help us understand how we can work on the different types of the probabilities and how we can use binomial dist by manipulating the probabilities. So let's start with identifying information that is available here. And so you can see that we have 32%. So that is the probability of success. First of all, let's write X. What are we interested with? We are looking at number of students who participated in a community volunteer program. So students who participated in the program. So X will represent the students who participated in the program. And then let's look at N. So what is the number of trials? The number of trials is 30 students, and therefore here we're going to write 30 students. And then probability of success. So we need probability of success, which is 30%. So we know probability of failure, which is 1 minus probability of success. And so I'm going to put equal sign there, type 1 minus the 30%. So we get probability of failure, which is 70%. Now we need one more information. We have N, we have P, and we have X. So if we need another information, will actually depend on the questions which we have. So let's go with the first question. We are looking at the expected value. So I'm going to write 1 here, and in this case here, we are looking at what is the expected number of students in the sample that participated in a community, the expected number. So that is actually the expected number of students participated in the program. So to get the expected number of students, that is actually the average. We're looking at the average, and so we are going to select, we'll also look at the standard deviation. So we will use the formula, which is actually this one here, and I just copied and pasted the formula. So to get this, all we need to do is just to put equal sign, click on N, which is 20, number of trials, times the probability of success, which is 41%. And so we can get that one, which is 8.2 as well. Did I select from here? Oh, yes, from this question. So 20 divided by 41. And so actually the average is 8.2. But let's look at standard deviation as well. Although the question didn't ask about it, let's try to find the standard deviation. So I'm going to copy the formula and paste it here. And then let me try to reduce the size of the formula. And that one as well. So anyways, let me not waste time with this. So all we need to find is standard deviation. Just put equal sign and type SQRT. If at all we ask to find the standard deviation. So that will be why double brackets there, I have no idea, but all we are looking for, yes, it is the square root of, let me put N times probability, which is let me go up here, it is 20 times 41, which is the probability, and close the bracket. And then we're going to make this times 1 minus probability. So I'm going to type 1 minus the probability of success and close the bracket. And I believe I need to close another bracket, which is okay now, and you can enter. So look at the brackets, the way they are typed. And so so the square root should be 2 brackets, and then we should put times here. So I'm going to say yes. And so let me double click here, and we need to put times here. And that's what actually we have, times. So that's what we got. And it is 2.19. And let's go to the second question, which says the probability of exact. So we are working on example number 1. I apologize. Let me stop here. And I have no idea how did I come to this probability, but everything is the same as what we did before. So let me go to binomial Excel function number 2. This is what actually we're supposed to work on. So I'm going to put equal sign. I was surprised what's going on here. So remember here also we need to bring those formulas. So let me pick the formulas which we have here. I'm going to copy this formula and paste it here. And also the other formula, which is standard deviation formula. Let me copy it and paste it here. So anyways, let's find the expected number of students that participated. And so we know it is n times p. So I'm going to put equal sign, and n is 30 times probability of success, which is 30%. So we have that one, and we can provide our conclusion that the average, the expected number of students in the sample that participated in the program are 9. And let's find the standard deviation, although it's not asked. So I'm going to put equal sign there and type SQRT, which is the square root. I'll select the square root, and that will be the square root of n times probability of success. So n times probability of success, close the bracket, and then times, put another bracket, 1 minus probability of success again, close the bracket, and then close another bracket. So in this case, we'll find it is 2.50998. And next, we can look for the second question, which says, what is the probability that exactly 10 of the students in the sample participated in the program? So we are looking at the probability of exactly 10. Remember how to write probability of exact. So it can be written as probability of x such that x equals to 10. And that satisfies the requirements of the binomial Excel function. And so we can just put equal sign and we can write binomial test. We select our formula, function. And so we're going to start inputting the values. So we have 10. That's our the requirement, which it says what is the probability that exactly 10 of the students. So we have X number of students who participated in this program. And then the next thing is, let me bring this up. The next thing is the number of trials, which we have here, which is 30. And then with the comma sign. And then what is the probability of success? It is 30%. And then we are looking at the either cumulative or exact, but it is actually exact. So we're going to click on the false. And so you can enter, and you're going to get the probability of exactly 10 students participated in the program. You can write your conclusion, please. And now let's go to the next question. The next question says, what is the probability that at most, was this at most or at least? It says at most. So at most, it is, we can define that probability of at most 14 students participated. So how do we type that probability? We can write it as follows. Probability of x such that x is less or equal to 14. That's the probability of at most. So in this case, we'll just use the binomial distribution because this is probability of at most, which is satisfy the requirements. And so we're going to put equal sign and we type binomial distribution. And so in this case, we're going to put 14 and then we put comma. And so the number of trials, which is 30, and I have to click on the n, which is 30, and then probability of success, which is 30%. And in this case, we are considering cumulative, less or equal. So it is false. Sorry, it is true. And now you can close the bracket and enter. We have 0.98306. That's the probability that at most 14 students in the sample will participate in the volunteer program. So now the next question says, what is the probability that at least 6 students participated? So we need to write that probability of at least. So we can write probability of x such that x is greater or equal to 6. That's how we can write probability of at least. So in this case, we cannot find, or we cannot use binomial dist because condition is to have at most or exact. So we need to change this to at most. So we're going to type 1 minus probability of x such that you can see 6 here is included. So we're going to look at something which is less than 6. Anything that is less than 6, because 6 is included. But still, binomial distribution cannot work with this. So I'm going to write as 1 minus probability of x such that x is less or equal to 5. So what is less than 6 starts from 5 and below. 5, 4, 3, 1, and 0. So it should be less or equal to 5. Why did I put the bracket here? So this is how we can rewrite this probability to satisfy the requirements of the binomial dist function. So now in this case, we can put equal sign, click 1 minus the probability of x such that x is less than 5. And so when I write binomial, I'm going to write the binomial test. And so we're going to look at the number. So in this case, it is 5. And then number of trials is 30. And then the probability is 30%. And then the cumulative, yes, this is not exactly, but it is equal or less. So I'm going to click on the true. It is cumulative. And so the probability such that x is greater or equal to 6 can be found this way, 0.92314. So let's go here and try to work on the remaining question, which says, what is the probability that more than 6? So we need to write that probability and it is probability of x such that x is more than 6, is greater than 6. So we need to change this to be either exact or less or equal. So since it is the probability of greater than 6, we're going to look at 1 minus probability. So you can see that here 6 is not included. So we are going to say less or equal to 6 because 6 is not included here. So we're going to find something which is 6 and below. So less or equal to 6. This one, 6 is included, and it's actually it satisfies the requirements of the binomial dist. So we're going to put equal sign and then type binomial dist. And so we're going to put this 6, 6, and then the number of trials, which is 30, probability, which is 30%, and it is still cumulative because it's less or equal to 6. So we're going to select true and close the bracket and enter. So the probability that what is the probability that sorry, not number 5, it says, what is the probability that more than 6 of the students in the sample participated in community volunteer program? It is what we just get. So please don't forget to provide your conclusion about what you get. So that's example number 2. Now let's look at example number 3 and see if we can complete this. So this one says, in the 2013 Jerry's Artarama Art Supplies catalog, there are 560 pages and 1.5% of the pages feature signature artists. Suppose 100 pages are randomly selected from the catalog. So what is the probability that fewer than 3 of the pages in a sample feature signature artists? What is the probability that more than 5 of the pages in the sample feature signature artists? And what is the probability that at least 4 of the pages in the sample feature signature artists? So to start with, as we did before, we are going to see if this satisfies the binomial distribution kind of question. And we know that, first of all, we can consider x. And in this case, we are looking at the sample that features signature artist. So we're going to look at the signature. So we're going to look at the sample that feature signature artist. So the sample that feature, so sample that feature signature artist. So we are told in this year that we have catalog and there are 560 pages. So that is the total pages of the catalog. But our interest is looking at 100 pages at random. If you select 100 pages at random from this 560. So our N is 100. Those are the pages which we pick at random. So we need to find out if we have probability of success. So probability of a success is actually 1.5, and that is constant. So probability of failure, which is 1 minus p, or 1 minus probability of success. So we're going to put equal sign there, type 1 minus, click on the probability of success, which will be 98.50%. And then what other information do we have? So I think we have enough information here. It says, what is the probability that fewer than 3 of the pages in the sample feature signature artist? So we are looking at the probability. So let me go here. Probability of X such that X is less, it is fewer than 3. So we cannot say X minus 3 because that one is not at most. So we need to bring this to at most. So what discrete value is less than 3, or which value should we start to see they are less than 3? It is actually probability of X such that X is less or equal to 2. So now we have brought this to at most. So having done that, we can respond to all these questions. So we can go to what is asked. So we can put equal sign and we can type binom. The binom, sorry, we put equal sign. So you can select the binom dist. And so we're looking at the number, which is actually 2. So I'm going to put 2 there, and the number of trials, which is 100, and the probability of success, which is 1.50, and then that should be cumulative. And so we're going to click on the true, and then you can close the bracket and enter. You get 0.8. And now the second question here, it says, what is the probability that more than 5 of the pages? So let's define probability of more than 5. It is probability of X such that X is greater than 5. But that cannot be, we cannot use that for binomial distribution. So we're going to take 1 minus probability of X such that X should be less or equal to 5, because here 5 is not included. We are looking at something greater than 5 and it starts from 6 and above. But now here the complement of that is 1 minus probability of X such that X starts from 5 and below. So that actually satisfies the binomial function, which is binomial dist function. So you can put equal sign, and so you can go with the binomial dist function, and we're going to put 5, and so you just go with the number of trials, probability of success, and we're going to select cumulative, which is true, and enter. So we have 0.99591, and you can see how easy this is becoming. So that is the probability that more than 5 of the pages in the sample feature signature artist. Please provide that conclusion. So let's look at the next question, which says, what is the probability that at least 4 of the pages, at least 4 of the pages, so it is probability of X such that X is at least, so it is greater or equal to 4. That's the meaning of at least. But we cannot use binomial dist in this case, so we're going to write probability of X such that here you can see 4 is included, so anything that is less than 4, and here what is less than 4, sorry about that, so here we should put 1 minus, and still we cannot use binomial dist function, so it's going to be 1 minus probability of X. So what is less than 4? It should be 3, so should be less or equal to 3, which is start from 3. and then we use the same function, which is we put equal sign, binom dist, and in this case, we're going to put 3 and then the number of trials, which is 100, and then the number of trials, and then probability, which is 1.5, and this is also cumulative and it's true. So close the bracket and enter. So let me see here. Yes, we did the same, like everything. So 5b 13, which is n, and probability, yes. I'm going to add one more question here. So let me use this question, copy, and then let me have question number 4. This one, it says, what is the probability that between 2 and 4 of the pages in the sample feature signature artist? So I want to introduce to you the in-between probability. And so how do we write in between when we say between 2 and 4? So we can write probability as follows. Probability of 2, which is less or equal to x, which is less or equal to 6. Do we say 4? Yes, 4. So this is how we can write the in-between probability. It is 2, which is less or equal to x, and x is less or equal to 4. Please understand this. I didn't mention it when we were learning about how we can use how we can convert different forms of the probability to fit into exact and at least. So here you can see that we have probability of 2 that is less or equal to x. So let me define one after another. So we have a probability of actually x, which is greater than 2. That is the opposite. I mean, that's what it means here. Equal or less. So we can say here. So it is the probability of x such that x is greater or equal to 2. That's how we can rewrite this. X is greater or equal to 2, because we say 2 is less or equal to x. In other words, it says x is greater or equal to 2. And we have probability of x such that x is less or equal to 6. Sorry, not 6, it's 4. That's what it says here. X is less or equal to 4. So this one is okay, but we can use binomial dist because it satisfies the requirements. But this one has to change. In this case, it has to be minus. So I'm going to put 1 minus probability of x such that x is less than 2. So it is less than 2 because here 2 is included. So it should be now, because this still cannot satisfy the condition for the binomial distribution Excel function. So it should be 1 minus probability of x such that x, we're going to look at the value that is less than 2. It is actually 1 and 0. So it should be x is less or equal to 1. Starts from 1 and below. So that's how we can define this one here. So right here, therefore, we are looking at probability of x such that x is less or equal to 4 minus probability of x such that x is less or equal to 1. That's how we can now apply the binomial dist function. We have transformed this to this level. So by doing so, then we will use the binomial dist function, and I'm going to put equal sign and type binomial dist. We're going to start with this one, and so the number is 4, and the number of trials in this case is 100, put comma. So I put 100. Now I'm going to put probability of success, which is 1.50%. Click on that and put comma. And then we need to find if this is cumulative. Yes, it is cumulative. So I'm going to click on true. Close the bracket, minus. So we're going to minus this. And I'm going to write binomial dist. And so we're going to put 1. And we have 100, which is the n. And I'm going to put the bracket. Then probability of success. And then bracket. And still that is true as well because it is not exact. So I'm going to select the true here. And so we can enter, and we will get the probability of in between 2 and 4. It is 0.42575. So I'm going to ask you to complete example number 4 before you submit this homework assignment. So it says, during the 2013 regular NBA season, the Andre Jordan of the Los Angeles Clippers had the highest field goal competition rate in the league. This person scored with 61.3 of his shots. Suppose you choose a random sample of 8 shots made by this person during the year, during that year's season. So what is the expected number shots that scored points in a sample of 80 of these shots? So that, remember, that is the average. What is the probability that this person scored on 60 of the 8 shots? That's the exact. What is the probability that this person scored on more than 50? So you need to manipulate the probability to fit to the probability of at most. And finally, what is the probability that the person scored on between 65 and 75 of the 80 shots? So this is the probability of in between. Please complete this as your assignment. Once you're done, submit all of this, submit everything as your homework, as your classwork assignment for week 6. So in week 6, we worked on those examples on Tuesday and also on Thursday. So please, when you complete the assignment, just submit in week 1 and also submit in in assignment number 1 and resubmit in assignment number 2, because I just combined what we did in on Tuesday and Thursday. So please submit in assignment number 1 and resubmit in classwork assignment number 2. Remember, you have to complete example number 4 and then submit everything. Thank you. And also, I'm going to post the file that has notes in conjunction with the recordings for week 6. Thank you.